Here is I'm mirroring my Mac screen on here. So if it looks a little different, you're using PCs, a lot of these that you guys are borrowing here are PCs. If it looks a little bit different, that's the reason maybe the menus at the very top look different. As far as SPSS is concerned, which is mostly what we're going to be talking about tonight, the menus and the format is exactly the same. The operation exactly the same on the Mac and the PC. Stinks on both. It's buggy, it's slow, it's everything else. If you guys, anybody try virtual desktop yet? Okay, were you successful? It seems to be a little bit more stable than it was last semester, right? A little bit hard to work, a little bit slow, it's a little bit tricky knowing where you are. That's why it's better if you actually own it. Pretty inexpensive. How many of you guys have actually bought it and installed it on your computers? Okay, any disasters, any problems installing it? Yeah, that maybe, anybody have to call IBM to get some support? No? Okay, good. All right. You guys are much more advanced than the previous groups. Okay. So at any rate, if you do have problems, IBM support is usually pretty good on this kind of stuff. All right. So there is a document on Blackboard called BIOS610 Fundamentals. It's under the lab section, the lab tab, and there's several different data files. The first thing I'm going to do now is I'm going to start SPSS and open it just so we get an idea what it looks like when it starts up. Okay, and I'm going to go down here to the bottom. On your PCs, you're going to have your other test, your start button on the side. So if I can find it here, I'm going to start it from here. There it is. Bingo. Okay. Okay, so I'm going to get it started. It's going to bounce around for a little while. It's a little bit slow to start up. And I'm going to get kind of an opening window, kind of like when you first install Windows or PowerPoint, it gives you kind of like this choice of like different formats you can use and standard letters. You can, if you want, you can make that form go away. Just like now, I have this description, like you want to, here's some recent files I've opened. You can set a new data set. You can do several other operations, have several different other starting points. For the most part, I don't use that very much. You can click here, don't show this again if you want, so it doesn't come up again. So I'm just going to cancel it. And what happens is I wind up with a data data window for SPSS. Here is our, whoops, I'm going to move that out of the way. Here's our data window. Okay, it's empty. What does it look like to you guys? What's it similar to?
So actually,
yeah, it looks like Excel, right? Yes.
On the virtual desktop, they ask you if you want Unicode encoding.
Oh, you just say yes to that.
No, it's Unicode encoding or local encoding.
Is there a default? I think there's usually a default. Choose one. So choose Unicode encoding then. What they did, the older versions of SPSS used a different encoding format. Like in other words, kind of like, ASCII represents a certain set of letters, like digitally represents letters in a certain way. SPSS had its own way of encoding and encoding and compressing data so that the data files are small. So you can use the old way, you can use the traditional old way, which is for SPSS 10 or 12 or something like that, way, decade ago. Or you can use the new way, which I think is the one that you chose, right? The Unicode, right? So you can choose that. It's possible that, if you find some relic computer, it might have SPSS 9, and you might not be able to open it on it, but I wouldn't worry about that. Most versions in the last decade will work fine with this. And I think after a while that may go away after you choose it enough times, or there may actually be a spot in the preferences somewhere you can ask it not to ask it again. So like that, you can just get rid of that. So it looks kind of like Excel, except it's not really Excel. It's just a storage area, an organizing area for data. You cannot click in here and create a function or do an operation or something like that when you can in Excel. You can't add it, have that cell represent a total or something like that. What you can do is you have columns and you have rows. And in the rows represent cases. For instance, if you do a survey, the first respondent would be in the first row. The second respondent would be in the second row. Or if you're doing a hospital survey, the third patient, third row, fourth patient, and so on and so forth. So each one of those represents a case. Vertically, you have your variabilities. And your variabilities could be male or female, could be age, could be address, could be a code number representing the patient social security number, maybe, or something like that. So each one of these columns represents a specific variable that each one of these different cases may have. So it's variable because each case might have their own value for that. Okay, in the case of numerical variables, it's going to be a number. In the case of categorical variables, it's going to be possibly a word. But very frequently, you want to avoid using words for variable values. So for instance, if I'm going to call that, let's say I'm going to call that gender. So let's say the first person, the first case happens to be male, right? Second case happens to be female. Third case happens to be male. What did I just do there? It's probably pretty hard to see. You can see it on your computers mostly. Yes.
It's I guess case sensitive.
Right, it's case sensitive. So and it's spelling sensitive. If you misspell it or something like that, it's not going to recognize those two males as being the same value. Right? So a good way to get around that is to say that from now on, 1 is going to represent male and 2 is going to represent female. And this will represent 1. So it's going to lower the number of keystrokes you have to do. It's going to make it less likely you're going to make an error. But now we know that 1 represents male, 2 represents female. Now we have to make sure that SPSS knows that that's the case. So what we can do now is we can take a look at another side of this window, literally kind of a flip side of this window. If you go down to the bottom, you'll see there's a choice there that says data view and variable view. Okay, if you guys have SPSS on these machines and you want to open it up and follow it with me, it might be a little bit easier than seeing the small print on here. Okay, unfortunately, almost every Mac window program has a option where you can like zoom, just like on the trackpad, just push your fingers apart and zoom. It doesn't work in SPSS, unfortunately. So, I know what 1 and 2 represents. Now I have to let SPSS know what it represents. Down at the bottom, I can switch between 2 views for this window: the data view that it's in right now, or the variable view. Okay, just by clicking back and forth there. If you don't see that tab at the bottom, it's scrolled off. You can go up to view, and you can actually switch between them. You can slide down here, go to the variable view. Slide down here, go to the data view. That's a toggle. Whenever you check something off and to change to the other thing, that's kind of a toggle switch, right? So I'm going to go to the variable view. And in the variable view now, each line represents the variable. In other words, there's a line for each column that we had before. So each line, the only thing we've put data into so far is that first column, right? So that first column is now a variable. And it gave it automatically a name, VAR0001. Well, I'm going to go in there. I'm going to change that. I'm going to call that gender. Whoops. Okay, now the variable name is for that column is gender. Okay, and so now just a couple of rules about the variable names. They have to start with a letter. They can't have any spaces or unusual characters. I think they might be able to tolerate an underscore, but that's probably the only thing. I don't even think they have that. I think it's got to be strictly letters and numbers, and there's a limited size. Pretty big, but yeah, I don't think you'll run into a size issue. But you generally don't want to make those too long anyway. So I'm going to call that variable name gender. And you want to know something quickly? If I go back to the data view, now you're going to notice that the column, that first column now says gender on it. Okay. By the way, I'm recording this. I'm gonna record and cut this up into snippets so that I can upload it to YouTube, and then like later on you can go home and you can see that maybe if you're in the back there or you don't have SPSS working on the machine, you can actually be able to see this a little bit better. So at any rate, so I'm going to go back to the variable view and I'm going to give it some more information. The next column in the variable view is the type of data that it is. Is it a string variable, letters and numbers, or is it a numerical variable? You have a few choices there. If I click into it, it shows you all the different choices you have. For now, I'm just going to leave it a string variable. If it were a number, I would want to change that to a numerical variable. Okay, so next I'm going to go into the width. And right now, SPSS is allotting 4 columns, four digits to this variable. I'm going to leave it like that because it's only 1 digit anyway. I'm only using 1 digit anyway. No decimal places. I'm going to leave that alone because we're only putting in ones and twos into that space. Then we come across a column that says label. Well, let's say gender's not specific enough for you. Sometimes we're going to have variable names. They're going to kind of be acronyms or something like that, like P943T, patient 943 terminal, or something like that. So we might use that as the case number or patient number. We might want to make that more descriptive. So for gender, I might put in here something like sex of patient. Okay. So now if I do that, if I put a label in here in that cell, SPSS from now on, if it creates a table or a graph, instead of using gender, it'll use the word sex of patients. So if your variable name is GME or something like that, and you want that you don't want GME to appear there, you want something more descriptive to appear, you can just put something more descriptive in the label. And in there, you can use any characters you want, and you can have spaces. Okay? So next one is values. Well, now values, if you have a numerical variable, the value is just what that number is. If you have a categorical variable, what kind of variable is gender? Categorical, right? Nominal or categorical, whichever term you want to use. If you have a categorical variable, then you're going to have specific values for that. For instance, if instead of gender I had picked hair color, right? You're going to have a set of possible values for that variable. Brown, brunette, red, green, blue, whatever. It can get pretty interesting. However, now that's our opportunity now to tell SPSS what our abbreviations for those variables are. So I'm going to put in here that value 1 represents, that was male, right? Right? And I'm going to add that to my value labels. And I'm going to say the value 2 represents female. And I'm going to maybe I'll even say 3 represents unknown. And click add. So now I've defined for SPSS what the variable values are. I'm going to click OK. In the next column, I can tell SPSS is missing. If I click into that, I can describe to SPSS how I want to indicate when a value is missing. So in other words, I could actually tell it to whenever we're going to have a values missing because the person didn't want to give us that information, like for ethnicity, the form it says, I don't want to report that. You could say that's represented by 9. If you forgot to ask, that could be represented by 8. If it wasn't clear on the form, it was the handwriting was poor, that might be 7 or something like that. So you could just define those. In fact, if you just leave a cell blank, SPSS will figure it's missing data. We'll ignore it. So I'm not going to worry about that right now. And then it's going to give me some other options about how the data is displayed in the data file, in the data window. Do we want to align it to the left? Do we want to center it? And so on and so forth. The type of data it is. Now that's important. SPSS will allow you to define 3 different kinds of data: ordinal, nominal, and scalar. Oops. Yes. I just picked unknown, yeah.
Doesn't that mean that unknown means that the data might be missing from your data set?
Well, yeah, you would decide if that's what it means. Okay, in other words, this is up to you to decide. What does unknown mean? I didn't collect it. Yeah, I want to know something? I'm going to go back. Now that you brought that up, I'm taking that one away. I don't like that one. You're right. That's sloppy. Why not? You have a choice. You could assign a number to missing data and make that, and then tell it that if it's that number, this is the reason why the data is missing. Okay, so I'll take that out now. I'm sorry I put that in now that you mentioned it. Okay, nominal, ordinal, and so on and so forth. So now it's a string variable. You notice it won't let me choose scalar, only let me choose nominal and ordinal. That's because I told it was a string variable. It's not numerical. If I change this to numerical, which for our purposes, it's a number anyway, right? 1 or 2. So SPSS will be perfectly happy with that. right? I'm going to put it in numerical. Now it'll let me choose any one of those three choices. You only got three choices: scalar, which is a numerical variable, ordinal, or nominal. Okay, so I'm going to go back to the data view. Now when I go back to the data view, I still see what I saw before, just ones and twos, right? Now if I go up to view and I go down to value labels and click on that, it'll let you see what those values actually represent: male, female, etc. If I go back to view and unclick value labels, it'll go back to what the actual number that you put in there is. Okay, so pretty simple, right? Okay, and that's how we basically work with SPSS. We have two windows like that. There is well, it's really one window. Kind of, you can imagine it kind of as a window with two sides, right? You have the data view and the variable view, but they're connected together. If I want to save this, I can go up here and say save as, save it to my memory stick, save it to my desktop, or so on and so forth, right? And that's saved. Now, let's say I perform an operation. For instance, I'm going to go up here to analyze. I'm going to do our first very simple operation: descriptive statistic frequencies. And okay, descriptive statistics, we know that can be, be just a simple count with numerical variables like how many males, how many females. It can be, if we have a numerical variable, it could be things like mean, median, standard deviation, and so on and so forth. But right now we have a nominal variable. So I'm just gonna ask it to give me a count, a frequency count. So instead of choosing anything else, I went into analyze, descriptive statistics, frequencies. Just give me a count. Okay, and I'm going to tell it which variable. Now remember that when we do this now with a real data set, there's going to be a lot of variables. So I'm going to tell it I want to work with this particular variable by moving it into the variable box. And I'm not going to ask for any statistics because I'm not interested in statistics for this, just frequencies, because it's a nominal variable. It doesn't mean male and female. It doesn't mean anything to have an average of that. Okay, so I'm going to click OK. And what happens now is something interesting. We got a new window, an output window. So SPSS, every time you do an operation, SPSS pulls up an output window. So this output window, if you look at it, the first thing it does is it gives you a description, a text description of what just happened. Well, what happened? Frequencies of variable equals gender, okay, and ask it and do the analysis, basically is what that says. That is what we just did in SPSS's script language. Somebody just asked about the script language or its syntax before, where you could actually program it using words. Literally these words, if you had used these same words with this file open, you would have gotten the same output from this. Okay, you can actually learn this language and actually use that language to do repetitive analyses on data and so on and so forth. So, okay, that's what we just did. If we didn't want to use the menu, the drop menus. Okay, so it did frequencies. And what did it tell us? If it said it had three valid results, right? It had no missing values. And it found that two of them were male, one was female, 66.7% female, 33% female. It gave me a cumulative percentage as well, 67%, and so on and so forth. So it gave us some information about that. But notice it did it in a new window, right? So this new window now is separate from the data window. If you want to keep this window, you have to save it separately, or you have to export it. You can export it into different formats, like rich text file, which is kind of like a Word document. Okay, and you can open it in Word. You can also, if you want, open a Word document. Okay, and I'll open a new one, blank document. And you can go to this output document. You can click on one of the charts that it just created, say copy, and paste it into this window. Bingo. So if you want to use that data in a report or another class or something like that, it makes it very easy for you to output this data and use it in somewhere else usefully. Now, there's a couple of ways you could do this. One way is to just paste it in like that as a table. If you click in here, it gets a little complicated. See all the tabs and stuff like that up there, because you can actually go in there and you can actually edit this or reformat it in a word processing program. Sometimes when you use, sometimes that's a good thing, and sometimes that's a bad thing. I didn't notice it cut it out. It didn't. I thought I said copy. Did I say cut? I guess I did. Okay, I'm going to undo. Oh, there it came back. Okay, good. Okay, so now if I do another analysis, I'm just going to do the same thing just to show you what's going to happen. Frequencies, and say okay. Did the same thing again. It kept the same output window. So now you literally, all of the work that you're doing as you work with SPSS is being sent, your results are being sent to that output window. In fact, there's a little navigation window on the side here that when you have like a whole string of analyses that you've done with a lot of tables and charts, you can actually use this kind of navigate around, kind of like an index. Okay, so if I produce a graph, it's going to be on here as well. So we're going to play around with this with some real data. Yes?
Can you save the output page? Or
You can, yes. In fact, yeah, you can say save as, and it's going to save it as a different kind of file. The data files are .sav files. The output files are .spo files, right? So I usually try and save them also as a rich text file because that you can actually cut and paste the tables from. And sometimes the output files can be a little bit hinky opening up in different versions of SPSS. So I like to save them also as a rich text file. But yeah, if you don't save it, it's gone. If you only save the data file, if you only have the data file open when you quit SPSS and only save that, you're going to lose the output file. Okay. So, and the other complicating factor, if you use virtual desktop, you got to remember where you're saving it to. When you say save as, you have to navigate to a place where you're going to be able to retrieve it. By default, it's going to try and save it on the server, on the computer here at Hunter that's running at School of Public Health that's running virtual desktop. So you have to go up there and navigate to your computer and to your hard drive and to your user area and to your desktop and save it there. So just keep that in mind when you're on if you're using virtual desktop for SPSS, make sure when you save your work or a file that you navigate back to your computer to save it in a folder on your computer and not save it on the server, because on the server every night at midnight they just erase everything. Okay, so let's work with some real data. Okay, and there's a couple of ways I can do that. I can if you want, you can download this data file in North Carolina birth 800 mod.sav. You can download that. The easiest way to do that would be to right click on it, say save link as, and save it onto your desktop on whatever local computer you're using now. Okay, once you do that, there's two ways you can open this. One is just go to SPSS, and you can say open. Whoops. Oh, I got the outdated one. Open. Did you notice this is kind of, what did I just do here? Oh, I was on the Word document. It looks like an SPSS file, but it's a Word document. Open. Yeah, am I still in Word? Yeah, you're right. I'm still in Word. Oh, yeah, that's right, because I saved this here. Where'd it go? Where'd SPSS go? Hang on a second. Okay. You have this big screen up there. Not so big from your perspective, big screen up there. But I'm working on this little laptop and hard to find my way around. Okay, here I am. I'm going to try another window. Okay, there must be something. I'm going to have to hide this stuff here because it must be asking me to do something in the background. Cancel. Okay, it's asking me to update Microsoft Word. That's why I can't work with this thing. All right, good. We got that out of the way. There's a little window waiting for a response though. Jeez. There still must be something that it wants in the background that's waiting for a response. Whatever I was trying to save. Oh, okay, maybe that worked. How's that? Yeah, now it's back again. Okay, SPSS. File. Oh, I couldn't find the window anymore, so I just hit escape and it went away. Open. Okay, so now open, working with the data file here. So you go to open, data, and you can navigate to the data file. In this case, I have to, just as I told you before, I have to go back up to Tony DeVito, go to my desktop. What is it? There's my desktop. go to, I think it's in this folder, start folder, and there's the file right there. I can click on that and open it now, or you can just double click on the file and open it just like most programs. It's running in Unicode mode, yes. Okay. Okay, so I've opened up a data file that represents data on 800 births in North Carolina, randomly selected births in North Carolina during a period of a year. There were many more than 800 births in North Carolina during the course of that year, but this is a sample from that population of births. So each one of these rows represents a birth, right? So if I go into this first row, each one of these columns represents a variable. Okay, it's, for instance, this first column represents plurality. Anybody know what plurality means? Well, think about it. It's a birth. Number of babies, right? Number of babies, right? Okay, and sex. We talking about sex of the mother here? Probably not, right? Because they're probably all female, right? So that's got to be the sex of the baby, one would think. And look, it's all ones and twos. So that makes sense. M age. Now here's an example. M age. If I threw that onto a chart or a table or something like that, unless they knew the context of this data, they wouldn't know what that variable meant, right? Obviously, that's the mother's age, right? So now what we want to do is we want to make sure SPSS, instead of using that variable word MH, that it instead converts that into something that makes sense when it makes a chart or something like that. Weeks, that's weeks of gestation. Marital status, that might be, I see ones and twos, there might be more. The race of the mother, whether the mother was Hispanic or not, for whatever reason they separated that data out. How much weight the mother gained, whether the mother smoked or not. Now notice it's zeros and ones, so it's a yes and a no, but they use different numbers to represent it. Whether the mother drank alcohol during pregnancy, and T ounces. Those are the total ounces for the baby at birth. What kind of data is that going to be? Ounces. It's going to be numerical, right? Okay. Weight of the baby at birth in grams. Low birth weight, yes or no? They pick a birth weight. They decided that under a certain weight is a low birth weight baby. Is the baby premature? That's based on the number of weeks of gestation and the ethnicity of the mother, ones and twos. I don't remember exactly why they have that column there. Okay, so let's take a look at this from the variable view. From the variable view, well, plurality, number of children. Notice that label now says number of children born of the pregnancy. Sex, sex of the child. M age, age of the mother in years. Okay, so now instead of that abbreviation, it's going to actually use that in the charts in the data. Okay, so how many of you guys actually have this open now? Okay, good number of you. Okay, for those of the rest of you, if you don't have it open, you can follow along with this anyway. Okay, so now let's take a look at this from the perspective, if I go to the value view now, for instance, the sex of the child, if I click in there, I'll see that one represents male, two represents female. I'll see that the marital status, one represents married, two represents not married, and so on. At this point now, for my analyses, I don't need to worry about this anymore because SPSS will deal with the coding. It'll deal with what that 1 and 2 represents. When we open the next file we're going to open up, we're going to actually code the file ourselves because it's uncoded. And that'll make more sense to you when we do it. So I'm going to go back to the data view. And let's do a quick analysis on, let's analyze something that is nominal data. What on here might be nominal data? Somebody pick one. Yes. What's that? Mother's ethnicity? Ethnicity, what you say? Where is that? That is the race of the mother. How's that? Or no, there's ethnicity too, right? Ethnicity. Okay, ethnicity of the mom. Okay, so let's take a look at that. Okay, how do we evaluate that? Since it's nominal data, we need to look at it in terms of frequencies. We're not going to do means, we're not going to do standard deviations, and so on. So I'm going to go to Analyze, Descriptive Statistics. My first choice is frequencies. And just like before, except this time I have many variables. So now I have to find the ethnicity of the mother, move it into the variable box so SPSS knows that that's the one I'm interested in. And statistics, we're not going to do any statistics on it. However, at least numerical statistics. However, I could ask it to produce a bar chart for me. I can click that right there and it'll make a bar chart for me. Okay, format, style, we can worry about that later on. I'm going to click OK and see what it does with this. Of course, what's it going to do first? It's going to open an output window. Well, in fact, in this case, we had an output window open already, so it's just going to add to that output window. So let's see what we wind up with. We wind up with a table that gives us the frequency, the number of Hispanic white women that gave birth, non-Hispanic white women, non-Hispanic black women, Hispanic, other. So this is the kind of an abbreviated variable set for ethnicity. Okay, so, and it gives us percentages, and then it also gives us a bar chart. Okay, and there's others, missing values and stuff like that. We didn't have the data for that. Okay, so we have an idea of what the distribution of ethnicities are in this particular sample. Okay, there might be some better ones. Let's see what else we have here. Descriptive statistics, frequencies. What else might be interesting? Okay, let's take a look at that. Smoke during pregnancy. Now, I can do more than one variable at a time. So I'm going to analyze both of those at the same time. So I've got two tables now. And smoking data, I'm just going to go straight to the chart. And it looked like we had something like probably 680 women that didn't smoke and maybe 120 that did smoke. Okay. In fact, the table tells us that 684 and 114, 85% of the women didn't smoke and 14% did smoke. What about alcohol? We think it's going to be higher or lower? Right? Well, we have the tools now to find out, don't we? Right? I'm going to move alcohol during pregnancy. Let's see if there was a higher frequency of use of alcohol than smoking. Well, no, in fact, very few women admitted to smoking. How many is there? Only one? Is that really true? Let's see. Mother did consume alcohol. Mother did not. Mother did consume 4. They have a frequency of 4. It's less than 1%, right? So you can see that. So also remember, this is a survey. So they may be less likely to admit drinking during pregnancy than they might be to admit smoking during pregnancy. Not to mention the fact that they're probably smoking as they're taking the survey, as they're being interviewed. So kind of hard to deny. So at any rate, okay. So now let's do this on our own. We're going to open up another data set, okay? And I'm going to leave this data set open. I can have more than one data set open at a time. I'm going to open up another data set called Titanic. Open database. What's that? It's on Blackboard, right? Yeah, it's on Blackboard. Titanic. Titanic.sav. There's a couple of versions of it. We want the one that's .sav. Oh, I'm sorry. Okay. You want to know something? I did that on purpose. And the reason why I did that is because SPSS can import data from other programs. That's valuable because a lot of times the data that you're going to receive might be in a database format, might be in a tab delimited text file, comma delimited text file, might be in a lot of different formats. So I'm going to go over here to SPSS. I'm going to say open. I'm going to say data. Okay, and I'm going to navigate to where I think the data is. I happen to have it in this folder. If you have it on your desktop, that Excel file, that's fine. I don't see the file, right? I think it's in this folder. I don't see the file. Well, the reason why I don't see this file is if you look under files of type, right now, all you can see is SPSS data files, .sav files. So if I click on that, I have a lot of other choices for the file types that I can see, including Excel, or including all files if I wanted to. So I'm just going to tell it, look for Excel files. And bingo, all of a sudden now an Excel file appears. I wasn't able to see it until I told SPSS that the file type we're looking for is an Excel file. So there it is, titanic.xlsx. Okay, I'm going to click open. And it's going to open that. Now, first thing it's going to tell me is that there is data in the cells A1 through E1314. Anybody want to hazard a guess as to why 1314? That's the number of passengers, right? I would think. Okay, So it's E. We have 5 variables, A through E, and we have 1,314. I don't know if that's really the whole set of. It may be the only ones that they have records for. There were a lot of people that they probably didn't know in steerage or something like that. But they don't actually have records and names for or data for, or specific data like gender and stuff like that, or children or whatever. So that's what it tells me. Notice there's a little box over here, checkbox. Read variable names from the first row of data. When you're using Excel, it's not uncommon to put the variable name in the top row. And then underneath that, like in other words, name, addresses. So we don't want to use, that's not data, right? That's the variable name that's up there. So by leaving that checked off, we're telling Excel that's the variable name, right? Everything else below it is data. And it'll recognize that and put that at the top as the variable name. I think I'm going to leave that checked because to be honest with you, I don't remember. Okay, so it's going to import this file into Excel. And sure enough, look at the top here, it has ME, P class, age, sex, survived, right? It took that row, in fact, was the variable name. And now SPSS is using that top row as a variable name. And below that, you have the names of the passengers. You have the class that they were in, first class. You have their age, you have their gender, and you have whether or not they survived. Yes?
So for us to be able to do this, we basically have to download these files onto our desktop and then open them from Excel.
I think that's probably a better way to do it. Even if you could probably open them from the remote computer, right? But probably better to save it on your desktop and work there, because if something goes wrong, you still have that data there. Or when you save it, it'll save to your desktop as well, by default. Okay, so let's take a look at this. Well, now, okay, good. So, I can see that Miss Elizabeth Walton Allen is, well, 0 must mean female, right? Because the name indicates she's a woman. So I kind of know what that is. But what about the class is 1, 1, 2? I can kind of figure that out. What about survived or not? Does 1 mean survived or does 0 mean survived? Right? Well, the way we determine that is I'm going to go back to that folder that we had on Blackboard, or the data we had on Blackboard. And you may notice that there is something in there called a code book. Okay, and the code book for Titanic, see, this is the way these apps are supposed to work when they're written correctly, right? The code book tells me that name represents the recorded name of the passenger, P class, passenger class, first, second, third, age in years, sex is 1 is male, 0 is female. We figured that out. Survived, 1 is yes, 0 is no. Good news for what's her name, whatever her name was, right? She survived. Okay, so now we know what these represent. So now I'm going to go back to this file, and we are going to code this data. Okay, and where do we code the data? We don't code it in the data view. We code it in the variable view. Okay, good. So the first thing I want to do is I'm going to leave the widths to whatever they defaulted at. Okay. Notice 62 and string is for the name, so we know that makes sense. Okay, for the label, I'm going to put name of passenger. Okay, for the class, I'm going to put ticket class. Okay, and that's going to just leave that as a 1 or whatever. Okay, if you want, you could code that if you want, but I won't get to that. Age, I'm going to put age of passenger. Okay, for sex, well, that's a number indicated on there, but it's actually a numeric. It's actually a nominal variable. So now I'm going to go into values, and I'm going to tell it the 0 represents female. I think that I'm right about that. Okay, I'm going to click add. I'm going to choose 1 and tell it that represents a male. Okay, and if that's blank, it's going to be just missing data. I'm going to hit, and now you got to make sure to hit add. If you just hit OK, it's not going to take it. So you have to hit add and then hit OK. So now SPS understands that 1 represents male and 0 represents female. So now it's survived, right? We said 1 represents survived. It's actually in the code book. And 0 represents did not survive. Okay, and I'll click OK. Okay, I'll go back to the data view. Before I go back, I'm just going to check to make sure SPSS took the right guess at the variable type. So for name, nominal is correct. For passenger class, nominal is correct. For age, scalar is correct. For sex, nominal is correct. And for survived, yes or no, nominal is correct. Okay, so let's go in here and let's analyze this data. Descriptive statistics, frequencies, and let's analyze this for, I'm not going to bother with name of passengers because that's really kind of just, in fact, most data you're not going to know the name of the patient, usually separated out for privacy reasons. You just might have a code number, an identifying number, or something like that. So ticket class, let's see what percentage of people were in different ticket classes. Let's also see what the different genders were, the distribution of genders were. And let's see what the distribution of survived or didn't survive. I actually think there were a couple of thousand people, so I'm not sure that 1,300 is right. You can look that up. Somebody will look that up tonight. I'm going to click, and I'm going to tell it, give me the bar charts again also. Let's give me bar charts. Okay, and click continue. Okay, now when I click charts, notice I could have clicked pie chart if I wanted to, except bar charts are ridiculous. Nobody uses those. Let's see the bar chart. And I also could have clicked histogram, but histogram's not appropriate for nominal data, right? It's only appropriate for numeric data. So I'll stick with bar charts. Okay, and I'll click OK. And see what we get. And now it brings up our data window, and sure enough, here's our various outputs. Each one of these tables, 25% were in first class, 54% were in third class. Genders were 64% male, 35% female. Survived. 853 did not survive. 550 did survive from this sample. I don't know if it really represents everybody. Okay, and you can take a look. Yeah, look how more people were in steerage in third class as opposed to first and second class. Look at the distribution of male and female. Okay, so this is what the nominal data is going to give you, the kind of information nominal data is going to give you. Okay, how about ages, right? Let's look at the average age of people that were on this ship. Descriptive statistics. Now, instead of going to descriptives, I'm going to go over, instead of going to frequencies, I'm going to go down to descriptives. I'm going to click on that. Now, the only one of these that's a numerical variable is age. So notice that's the only one that I'm going to move in there. Options. Okay. Oh, mean, standard deviation, minimum, maximum, variance, range. I'll click a few more things off. And I'm going to ask it to go ahead and do that analysis. And there we are. We got a window at the bottom. It tells me the age range is 70.83. Okay. The youngest passenger was 0.17, I guess, years of age, an infant. The oldest passenger was 71. You go on a cruise nowadays, everybody's 71. Trust me, I've been on a few. So that's a whole, never mind. What's that? It's like maybe the baby was like 2 months old or 3 months old or something like that. Right? 3 months old would have been 0.25. Right, so this might have been 2 months old. Right, 71 is the oldest passenger. The mean was 30.3980. They don't give me something that would have been interesting here, do they? They don't give me the median, right? So let's take a close. There's a standard deviation, and here's the variance, kind of the way we calculated it the last time. Let's go back here to analyze and go to descriptive statistics, and this time go past the descriptives to explore. Explore is also going to do descriptive statistics, except it's going to give us an opportunity to look at it in a little bit more depth. Okay, and again, I'm going to move the age of the passengers into the dependents list. Don't worry about the factor list yet. I'm going to click OK. And look, it gave me a lot more information. It let me know that don't worry about confidence interval, we'll get to that. The median age was 28, and the average age was 30, right? The middle age was 28, and the average age was 30. So the average is pulled to the right of the median. What does that tell you? That tells you that it's not completely normally distributed. That there must have been more older people than younger people. So that would be skewed to the, I'm going to draw it. Hang on a second. Okay. Okay, let me see here. Okay, so say our distribution, actually, I'm going to be able to show it to you in a second. Okay, oops. So let's say that's a normal distribution, And this is the median and the mean are the same, right, in the normal distribution, right? Well, now if you have a distribution that looks something like this, where there's more older people, right? The median is still over here somewhere. So 50% of the people are here, 50% of the people are here. But the average now is pushed over to the right. So that is right skewed or positively skewed. Remember that we were talking about the ski slope, right? You got it on that side there. Okay, that makes sense to you. The direction that if you get a lot of people if you had a lot of infants on here, it would have pulled the mean to the left of the median. That would have been left or negatively skewed. If you have a lot of older people, pulls it to the right. The mean you're separate. If you separate the mean and the median, you're skewing the sample. Okay, so let's take a look at what this looks like graphically in SPSS. Okay, and SPSS didn't create a histogram for us. I'm going to go back to Descriptive Statistics Explorer. I'm going to tell it in plots to create a histogram. Continue. I'm going to click OK. It creates this nasty thing called a stem and leaf plot. Don't worry about that. I'll talk about that next week. We're a little bit short on time. But look at this. Can you kind of see this? Right? That these older people, right? Instead of being normally distributed, these older people are pulling the average up away from the median. Now, a further evidence of that is the box plot, right? What is that dark black line in there? That's the median, right? But look at this. The median is here. It should be in the center of the interquartile range, 25th percentile, 75th percentile, the 50th percentile. So the fact that it's down here towards the bottom tells you that you have a lot of older people. In fact, you have some outliers. They're much older than the rest of the people on here. You have some outliers that are pulling the median towards the top or positively or to the right, right? So you can actually see the skew in the histogram, and you can see the skew in the box plot. Right? As we go through the semester, this will become more familiar to you. So don't get nervous if you say, oh man, I'm never going to be able to figure out if it's positively or negatively. As you kind of set up your own mental rules, you'll look back at this night and it'll seem simple to you as we play with this quite a bit. Okay, so there are other ways we can produce graphs. We can produce graphs by going into a graph function in SPSS where we can actually ask it to produce a histogram, and we can tell it what variables to produce a histogram for, and go ahead and put the titles on it and so on and so forth. And again, you can click on this, copy it, and paste it into a document that you want to work with. Okay, so notice now we've done a lot of analyses here. Look at them all, right? So now if I want to get to any particular one, I could jump around this just by using this kind of index over here, right? If I want to go all the way to the bottom, I don't have to scroll down. I can just click on that. And again, remember, you want the output window, save it. You can also export it. Save as, and you can export it as a viewer file. And actually, I think it's, did I say? There is actually a command there that should say export. Export. And you can choose to export it as a Word or RTF document, star.doc. Right? And you can export, and that exports your, must be another one out there already. You can export it as a Word document. Right? So now our Word document has all these charts and boxes and charts in it and so on. So they can use later on to cut and paste it and stuff like that. Okay, we're at 7:45. I'm going to stop here. There's one more thing that with the lectures have been going a little bit longer. Right? Don't tell Pascal that I told you that. Okay, so they've been going a little bit longer, but and they'll get short as we go through the semester. They'll get a little bit shorter. I wanted to do a demonstration of age adjustment for you. I'm going to do it and record it, and then I'll upload it so you guys can actually watch it at home and stuff like that. Also, I'm going to cut this up into different sections, opening SPSS files. Maybe I'll just put it on as one video. So you guys can, if you want to rewatch this at home, you can redo it at home when you have your leisure and when you don't have to look from the back with binoculars. Silly thing. Okie doke. Okay, guys. Good night.